2.5. Recognize graphs of common functions. Use vertical shifts to graph functions. Use horizontal shifts to graph functions. Use reflections to graph functions. Use vertical stretching and shrinking to graph functions. Use horizontal stretching and shrinking to graph functions. Graph functions involving a sequence of transformations. Before we even start today, how confident are you with this chapter? Very, right? We worked really hard on stuff like this in Algebra 2, okay? So let me show you some graphs that they consider common graphs so you know what to expect, okay? Let's start with these three. You okay with these three? Linear, quadratic, and absolute value. We talked about these three a lot, didn't we? Okay? You all right with those? What about the next three? Exponential growth, exponential decay, and square root. Good with those? What about the next three? Cube root, cube, logarithm. Good. It's because I showed them to you before. That's why you've seen them before. And what about these? Everything with a yellow star by it is something we talked about in Algebra 2. You notice there's only one that we didn't talk about in Algebra 2. Okay? But does that make sense? There's 1, there's 2, there's 3, there's 4. What are there not anything of if we're talking about integers? There's not any decimals, is there? There's not any fractions if we're talking about integers. So it goes from 1 to 2 to 3 to 4. Excuse me. It goes from 0 to 1 to 2 to 3 to 4. No, there's no in-betweens, is there? Okay? How confident are you in all of these? Good? All right. So that takes care of our first one. Recognizing graphs of common functions, first objective, okay? Our second objective, I want to go ahead and just give you some notes, just so you have them written down nearby, just in case you've forgotten since we talked about it last, okay? That's not going to work. How about this one? Looks like it's time to get some new markers. What parent function is this? Or what, after transformations, what's the parent function before this all starts? Quadratic, right? Y equals x squared, okay? But all this stuff that's being added, that's what's causing the transformations, okay? So let's start by talking about A and B, okay? What is A and B doing to the rest of the function? It's multiplying, isn't it? Okay? When the multiplication happens, we either have a stretch or a shrink. Now, sometimes we call this a compression. I think the word that they use in their textbook, in their curriculum, is shrink. Okay? A is outside of the function. So what kind of stretch or shrink does it cause? Causes a vertical stretch or shrink. Okay. Where is B? Inside. So what kind does it cause? causes a horizontal stretch or shrink, right? If A equals 2, what kind does that cause? Okay. Vertical stretch. By a factor of 2. What if A is 1/2? Vertical. Yes, because it's outside. Shrink by a factor of 1/2. How do you tell the difference between a stretch and a shrink? So if A is greater than 1, it's a stretch. And what causes a shrink? Between 0 and 1, right? Okay, good job. What about B? Where's B? So what if B is 2? Horizontal shrink by a factor of 1/2. That's exactly right. Why is it a factor of 1/2? It's not the opposite. Remember, that's a sign issue. If we say opposite, reciprocal. Okay? So what about if B is 1/2? Very good. So what about H and K? What kind of movement does H and K cause? Shift. And what's the most important part of this word? The F. Excellent. We got to remember it. Without the F, it's something completely different. What kind of a shift does H cause? So it's inside. So that causes a horizontal change. And what about K? It's outside. So that causes a vertical shift. Okay? Guys, remember, anytime anything's inside, so B and H, is that going to be exactly what you think? Or is it going to be backwards of what you think? Yeah, inside is backwards of what we think, right? Outside's exactly what we think. If this is a 2, it's a stretch by a factor of 2. If this is plus 5, that moves up 5. It's exactly what we think it should be, right? If this says x minus 2, where are we going? To the right 2. It says minus 2, so we think it should go left, but it doesn't. It's backwards of what we think. It goes right. If B is 5, we think it's a stretch, but it's not. It's a shrink because it's backwards of what we think. Right? Any questions about that? You okay with transformations? That makes my heart happy. And here's the last thing you're going to have to be able to do. Graphing functions involving a sequence of transformations. Not all the functions that they're going to give you are going to look like this. Sometimes it's actually like a graphed function. Like that. And it's going to say, give me f of x minus 3 plus 4. And I need you to know what you're supposed to do with that. Okay? What do you think you're supposed to do with this function? So right 3 and up 4. What part of the function do I move right 3 and up 4? Like everything, right? All of it. So this point I need to move right 3. 1, 2, 3 and up 4. 1, 2, 3, 4. I didn't plan very well. This one. 1, 2, 3. 1, 2, 3, 4. This one. 1, 2, 3. 1, 2, 3, 4. This one. 1, 2, 3. 1, 2, 3, 4. I didn't ask it to change shape at all. I just asked to shift it, right? There's no multiplier here to cause it to change shape, correct? Do you understand this notation, though? That's what I was worried about. We did some of that in Algebra 2, but not a lot. So I wanted to make sure you understood the notation. You okay with that? But also, in that last objective where it talks about graphing functions involving a sequence of transformations, it could say something like f of x equals negative 2 times x minus 4 squared minus 5. Can you tell me how this changes compared to its parent? Tell me. That's a reflection across what? So let's go and write this up here. If this is negative, that's a reflection over the x-axis. If that's negative, if b is negative, that's a reflection. Where? Over the y-axis, right? Oh, you can't see that, sorry. So if A is negative, that's a reflection over the x-axis. If B is negative, that's a reflection over the y-axis. Okay? Got it? So looking back at our sample down here, we've got a reflection over the x-axis. We've got what? Yes. Yes. By a factor of 2. Vertical stretch by a factor of 2. And then we've got horizontal shift right 4. And then vertical shift down 5. Good job. You made my transformation heart happy today. Any questions on this?